GP stands for geometric progression. So how will you know a geometric progression? If I have something like 2, 4, 6, 8, 10, and the rest, and I have another sequence, let's say 2, 4, 8, 16, 32, and the rest. Now look at the first one. The first one, if you subtract the first one from the second one from the first one, you have 2. What do I mean? 4 minus 2 will give you 2. Also, if you check, 6 minus 4 will give us 2. 8 minus 6 will give us 2. 10 minus 8 will give us 2. You see that they have the same common difference. Once they have the same common difference, we call it an AP, arithmetic progression. But once they have the same common ratio, we call it a GP. How will you know the common ratio? Instead of subtracting here, we're not dividing in this. 4 divides 2 will give us 2. 8 divides 4 will give us 2. 16 divides 8 will give us 2. 32 divides 16 will still give us 2. So the common ratio here is 2. So this one is called a GP, while this one AP. Geometric progression, arithmetic progression. So now you have to find the common ratio given this. The nth term of a GP is given as AR raised to power n minus 1, where A stands for the first term, R stands for the common ratio, and N stands for the number of terms we are talking about. So from our question, our A is equal to the first term, which is 18. The common ratio is what we are looking for. And now our N is equal to 6 because they told us 6 terms. So if you want to write this in an equation now, the nth term of a GP is 2 over 27. So we have 2 over 27 is equal to AR raised to power n minus 1. What's our A? Our A is 18. Then we have R, which we are looking for. N minus 1 means 6 minus 1, which will give us 5. So I can put all over 1 here. If I cross multiply, or before cross multiplying, you can even divide 2 here 1, 2 here 9. Some of us will be surprised why I did something like this, but it will still work. Now if you cross multiply, 9 times 27, that will give us 300 minus, 270 minus 27, which is 243, if I'm not mistaken. Then R raised to power 5 equal to 1. So I multiplied these two, it gave me 243. Then R raised to power 5 equal to 1 times 1 gave me 1. So our R raised to power 5 now is equals to 1 all over 243. This implies that our R is equal to the fifth root, because our 5 is here, of 1 over 243. So now fifth root means which number will I multiply by itself 5 times to have this? So our answer becomes, which number will you multiply by itself to give you 1 5 times? Is still 1. 1 times 1 times 1 into 5 is 1. All over, which number will I multiply 5 times by itself to give you 243? I think that should be 3, because 3 times 3 is 9. 9 times 3, 27. 27 times 3, 81. 81 times 3, 243. So our common ratio here is 1 over 3.